What is trajectory optimization for perfect orbital insertion? Imagine guiding a spacecraft into a precise orbit around a planet or moon with minimal fuel and maximum accuracy. That's what trajectory optimization aims to do. It's a way to plan the best route and timing for spacecraft maneuvers to reach the desired orbit exactly as planned. This process involves calculating how much speed and direction change the spacecraft needs at each step. The goal is to use the least amount of fuel possible while meeting all mission requirements. Orbital insertion is the key moment when a spacecraft transitions from its transfer path into a stable orbit. Achieving perfect insertion means the spacecraft is exactly where it needs to be, with the right speed and position. This is important for satellites, space probes, or crewed missions. To do this well, mission planners use the laws of orbital mechanics and control theory. They consider gravity, atmospheric drag, and engine limits to find the optimal sequence of engine burns. Trajectory optimization models the spacecraft's movement and the environment around it. It takes into account gravity from the planet or moon, atmospheric effects if it's close enough, and even solar radiation pressure. It then sets constraints like the final orbit shape, the maximum thrust the engines can produce, and the time window for the mission. Using advanced math, it finds the control inputs, like when and how long to fire the engines and in which direction, that will get the spacecraft into the right orbit with the least fuel. This process also involves fine-tuning the spacecraft systems, such as engine design, to improve efficiency. The optimized path helps mission planners design the entire launch and insertion profile. For example, it can determine the best timing for engine burns to transition from a transfer orbit into a low Earth orbit or even an interplanetary trajectory. Modern tools for trajectory optimization use high-fidelity simulations that include uncertainties and perturbations. This makes sure the plan is robust and reliable. It allows for complex maneuvers like multiple engine burns, low-energy transfers, or interplanetary insertions. The result is a spacecraft that arrives at its destination exactly where it should be, using the least amount of fuel possible. In simple terms, trajectory optimization for perfect orbital insertion is about smartly planning every move so the spacecraft gets into the right orbit efficiently and accurately. It saves fuel, extends mission life, and makes space missions more successful and cost-effective.